Space, the final frontier, a place of infinite wonder and danger. But what happens if an astronaut loses their suit in space? Without a suit, the astronaut is immediately exposed to the vacuum of space. Within seconds, the lack of pressure causes the air in their lungs to expand and rupture the lung tissues. Holding their breath would be fatal. The correct response is to exhale to avoid this rapid expansion. Next, the bodily fluids start to vaporize. Blood and other fluids would boil at the normal body temperature, causing a condition known as ebulism. This leads to swelling, though the skin would prevent the body from exploding. The lack of oxygen quickly causes hypoxia. The astronaut would lose consciousness within 15 seconds due to oxygen deprivation to the brain. After around 2 minutes, they would likely die from asphyxiation. The extreme temperatures in space, ranging from the intense heat of direct sunlight to the freezing cold of the shadows, would also affect the body. In sunlight, the body would heat up rapidly, while in the shadows, it would lose heat and freeze. Radiation is another deadly factor. Without the suit's protection, the astronaut would be exposed to harmful cosmic rays and solar radiation, which could cause severe cellular damage. Despite the gruesome details, space agencies design suits to withstand these dangers, ensuring astronauts remain safe. But the terrifying reality remains. Space is a hostile environment, and losing a suit means a swift and inevitable death. However, let's delve deeper into each of these phenomena to understand their true impacts. The vacuum of space is a concept often referenced, but not fully understood by many. Unlike Earth's atmosphere, space has no air, no pressure. On Earth, our bodies are under constant pressure from the weight of the atmosphere. This pressure is balanced by the pressure of the fluids in our bodies. In space, without this external pressure, the difference causes gases within our bodies to expand. The immediate consequence of this in a spacesuit breach is the rapid expansion of air in the lungs. This expansion can cause the alveoli, tiny sacs in the lungs where gas exchange occurs, to rupture. This is why exhaling is crucial. Holding one's breath would exacerbate the damage, causing lung tissue to tear apart. As the body is exposed to the vacuum, another immediate effect is the vaporization of bodily fluids. Our bodies are composed largely of water, and in the absence of atmospheric pressure, this water starts to boil at the normal body temperature. This phenomenon, known as ebulism, causes the formation of gas bubbles in bodily fluids. Blood in veins and capillaries would start to boil, leading to swelling of tissues. The skin, which is elastic and robust, would prevent the body from exploding, but the swelling would be extensive and painful. Hypoxia, the deprivation of adequate oxygen supply, is the next critical issue. In the vacuum of space, there is no air to breathe. Within 15 seconds of exposure, the astronaut would lose consciousness due to the rapid depletion of oxygen in the blood and the subsequent lack of oxygen reaching the brain. This quick onset of unconsciousness is merciful in a way, as the astronaut would not be conscious to experience the ensuing effects. After around 2 minutes without oxygen, brain death would occur, leading to a cessation of all biological functions. Temperature extremes in space are another major threat. Space is not uniformly cold. In direct sunlight, temperatures can soar to 250 degrees Fahrenheit, 120 degrees Celsius, while in the shadow of an object, temperatures can plummet to minus 250 degrees Fahrenheit, minus 160 degrees Celsius. An astronaut exposed without a suit would rapidly experience these temperature extremes. In sunlight, the body would heat up quickly, causing severe burns and heat stroke. Conversely, in the cold, the body would lose heat rapidly, leading to hypothermia and freezing of tissues. The absence of an atmosphere means there's no medium for convective heat transfer, so the body would either absorb heat rapidly or lose it through radiation. Radiation in space is another invisible killer. Earth's magnetic field and atmosphere provide protection against cosmic rays and solar radiation. In space, without a suit, an astronaut is exposed to high levels of ionizing radiation. This radiation can penetrate cells, causing damage to DNA and other cellular structures. Acute exposure could lead to radiation sickness, characterized by nausea, vomiting, diarrhea, and hemorrhaging. Long-term exposure increases the risk of cancer and other radiation-induced diseases. The suit's material is designed to shield against this radiation, but without it, the astronaut's body is defenseless. Space agencies have spent decades perfecting the design of spacesuits to counter these lethal dangers. A spacesuit is a marvel of engineering, providing a stable internal pressure, oxygen for breathing, and protection against temperature extremes and radiation. The suits are designed to be flexible, allowing astronauts to move and work in the harsh environment of space. They are equipped with communication systems, cooling garments, and visors to protect against solar glare. Every aspect of a spacesuit is tailored to ensure the survival and functionality of astronauts in space. The process of donning and doffing a spacesuit is meticulously planned and executed. Before a spacewalk, astronauts undergo rigorous checks to ensure the suit is functioning correctly. Any breach or malfunction is addressed immediately. The suits are tested for leaks, pressure stability, and the integrity of the oxygen supply system. During a spacewalk, astronauts are in constant communication with mission control and their crewmates. Any sign of a problem is reported and managed promptly. These protocols are in place to prevent the very scenario we are discussing, the loss of a suit in space. The training astronauts undergo is exhaustive and includes simulations of various emergencies, including suit breaches. They practice procedures to manage a sudden loss of pressure, including how to seal minor leaks and return to the safety of the spacecraft quickly. This training is designed to maximize their chances of survival in the event of a real emergency. The psychological aspect of training is also crucial, preparing astronauts to remain calm and focused under extreme stress. Space exploration is inherently risky. The hostile environment, the vast distances, and the reliance on complex technology mean that every mission carries significant risks. However, the rewards of space exploration, the scientific discoveries, the technological advancements, and the potential for human expansion beyond Earth drive humanity to continue exploring. The loss of a spacesuit is one of the many dangers faced by astronauts, but the rigorous training and advanced technology developed by space agencies aim to mitigate these risks. In conclusion, losing a suit in space is a catastrophic event with immediate and fatal consequences. The lack of pressure, oxygen, and protection from temperature extremes and radiation would lead to a swift and inevitable death. The gruesome reality underscores the importance of the engineering and protocols that keep astronauts safe. Space is a hostile environment, but with the right technology and training, we continue to push the boundaries of exploration and discovery.